A sample of 45.0 grams of propane, which is C3H8, was burned to heat 500 grams of water, 500.0 grams of water. If the temperature of the water was initially at 20 degrees Celsius and it increased to 70 degrees Celsius after heating, how much heat was applied and what is the enthalpy of propane? So we are answering two questions in this example problem. The first thing we need to find is how much heat was applied. And we know heat is found by using the formula Q equals M times C times delta T. And Q stands for heat, and we get units of joules. M is the mass in grams. C is the specific heat capacity, which has units of joules per gram degree Celsius. And then delta T is change in temperature. And temperature, in this case, is in degrees Celsius. So the first thing we're going to need to do is solve for Q, because Q is how much heat is applied. So that's our first problem right here. And since we are measuring the temperature change of water, we're going to find how much heat was applied to the water to change its temperature. So, hear my dog's drinking water right now. So we're going to solve for Q. And since we're finding the temperature change of, since we measured the temperature change of the water, and we're finding how much heat was applied to increase the temperature of the water, we're going to solve for Q for the water, which means we need to put in the mass of the water we used, which is the 500 grams. So this 45 grams that we have right there, we're going to come back to that later when we answer this enthalpy question. So the 500 grams is the mass of the water. C, the specific heat capacity, that's a constant. And the constant for water is 4.18 joules per gram degree Celsius. And then the temperature change was from 20 up to 70, which is a total of 50 degrees Celsius. So having all this information, that's going to help us solve for Q. So we are going to take our 500.0 times 4.18 times 50.0. And with significant figures, the least amount, these both have 3, which means our answer should be rounded to 3 significant figures. Well, we get 104,500. So first of all, before we even worry about significant figures, I'm going to be converting, because heat is in joules, but our enthalpy is in kilojoules per mole, which means we really need this to be in kilojoules. So we're going to take the decimal that's technically at the end of the number, move it 3 places to the left, because that will get us from joules to kilojoules, which means we're going to have 104.500 kilojoules. But now let's round to the correct number of significant figures. So we said we needed 3, which this would be the third significant figure, because there's 1, 2, 3. Well, since there's the 0.5, that means this needs to round up, which means we really have 105 kilojoules. Well, now we've answered the question of how much heat was applied. So there's our answer for that, 105 kilojoules. Now the next question is, what is the enthalpy of the propane? Well, to find that, we need to know the kilojoules per mole. And actually, let me address one other thing. We came out with a positive 105 kilojoules. That's how much heat the water absorbed, which was how much was applied. However, since the propane was releasing all that heat as it burned, that means that the propane has negative 105 kilojoules of heat released. Well, and we need to divide by the number of moles. Well, how are we going to get number of moles to get the enthalpy? Because that's the unit for enthalpy, is kilojoules per mole. Well, to find the number of moles, that's where this 45.0 grams comes in. We need to take that and convert it to grams. So we have 45.0 grams of propane. I'm going to put it over 1, and we need to multiply by the molar mass. So in every 1 mole of C3H8, we need to know the molar mass. Well, carbon, we have 3 of them, times the 12.01 for its molar mass from the periodic table, plus we have 8 hydrogens times its molar mass, which is 1.01. So our molar mass of propane is 44.11 grams per mole. And now that we know this, that cancels our unit of grams of C3H8, leaving us with moles, which means we're going to take 45.0 divided by 44.11, and we get 1.02 with the right number of significant figures, so 1.02 moles of C3H8. Now that we know that, that's what's going to go into this position right there. So that means we have negative 105 kilojoules per 1.02 moles of C3H8. Let's find what that is. So 105, there we go, divided by 1.02 gives us 102.9. Well, we need three significant figures, and it is going to be negative, by the way. So negative 103 kilojoules per mole. And that is our answer for the enthalpy. So this is the heat applied, and this is the enthalpy.